Good morning, everyone. It's Tex here from A2K. And thanks for joining us for today's webinar. Civil 3D is not just a design tool, it gives you the power to author data. Technical consultant Dean will be presenting for us. So first, we'll just go through about A2K. We're all about fostering innovation through consulting and training. A2K Technologies plays a vital role in helping the infrastructure, building, mining, construction, architecture, and manufacturing industries reach full potential by delivering complete technology solutions and support services such as education, consulting, and IT managed services. We're working with visionaries to shape the future of design and in turn enable them through innovation to minimize risks, improve productivities, and achieve excellence. A2K Technologies is considered the business partner of choice and trusted advisor by vendors and clients. We partner with major software and hardware vendors to meet our clients' technology needs. We strive to exceed client expectations by understanding the challenges and delivering solutions through experience and innovation. We work with clients and companies of any size nationally and abroad. Over to you, Dean.
Thank you, Dexter. Good morning, everybody, or good afternoon, as the case may be, depending on your time zone. So we're going to be looking at authoring the data in Civil 3D. So the first thing I had to ask was, well, what is authoring? So it's talking about you've been given a design by a consultant or another designer, and you want to be able to check that against itself, get some numbers out of it, make sure it's all making sense. And so we can do that in a simple sense with Civil 3D and with some of the simple tools without having to go into the whole design process. So that's what we're going to be looking at. Now, if you've had a look at the little blurb for this webcast, the things we're going to be looking at is part of the new Project Explorer tools. Now, that's a new component for Civil 3D. We might be looking into that in a subsequent webcast a little bit more deeply, but we'll just have a quick look at that and what it can do at this point in time in this webcast. Then we'll be looking at volume and quantifications, with civil entities, civil surfaces, but also we'll be looking at a surface or a surface like you would get from 12D. And we can use Civil 3D to do volumes off those. Then we'll have a bit of a look at the ways we can represent or display the designs we've been given for public consultation. And we'll possibly also look at a bit of the publishing BIM 360 to be able to share the designs we've been given with other users, our own other parts of our companies. So let's go and have a look at that. The first thing we want to look at is the new Project Explorer. Where is it? So you do have to have the AEC collection, and when you go into your Autodesk account, you'll see that in there. If you go view items on the right, it's a new element that's been put or item in the AEC collection called Civil 3D Project Explorer. Then you can go and download it from there. It is for version 2021, which is what I'll be using today. But if you load that, it'll also load on your 2020 at the same time if you're using 2020 version. So we do have a lot to get through today. So I'll just jump straight into the demonstration. So here's a little example of something you might have been given as a little road widening design that's been done. We've got some pipes and things in here, some new drainage off that street widening, mapping into some existing pipework. There's a few surfaces and alignments and things, but basically, well, the design has been done. This is based on a surveyed surface underneath here, and we can have a look at those. Probably the easiest way to start looking at those is to put some labels on them. So we've got an actual surveyed surface underneath here. If we have a look at the existing ground surface, which is these grey triangles, we can just pick them, right click and go Object Viewer. And that's a very good tool for seeing what's going on. So here is the Object Viewer. That is a 3D view. And you can see there's a median in the middle of the two lanes on either side of the existing road running through here. And this is the existing terrain. And we're actually putting a widening, or rather the consultant has already put a widening into there. That's the design that's been done. So what would be nice is to check that the crossfalls of the existing road match the crossfalls of our widening. So there's not putting a lump or a drain into the middle of the of the surface. So we can compare this surface versus the design surface we've been given. And we can do that to begin with very easily with a few labels. So if I come down here, I pick any surface I want. Actually, I'll pick the EG surface, would be better. That one there, the grey. It actually tells you up in the ribbon that you've picked the existing. And we'll put in some labels, go add labels, add surface labels. And we'll just put in a slope label, go add. We're going to make it a 2-point label. So we're going to label between the 2 points that we choose. So in this case, I'm going to choose a point here in the roadway surface and go out towards the edge of my design, which is here. And I can see there's a 3.1% slope there. Now, if I pick another one here, and I'll turn off my object snaps there, just like Autocad, and here, you can see that is giving me a 4.6%, but that is because I'm still measuring the existing ground surface. But what we can do is any one of these labels that we've put in there, if we bring up the Autocad properties like you would do in Autocad, you can tell it to actually sample a different surface. So I'm going to tell it to sample my final level surface that's been given to us. And there we go. We're matching the final level surface, one of the yellowy contours, has got the same slope as the existing. And we can actually duplicate those labels. So if I pick that one and that one, go Autocad copy, which is, actually get rid of that now, which is just CO, enter. We can find it in the ribbon. And I can duplicate those up the road, and you'll actually see that the grade does change. So it is actually a surveyed or a slightly wonky surface underneath there. Oh, that one's probably jumped outside. Okay, I see what's happened there. You do need to be a little bit careful. Now, there will be perhaps small changes, 0.1% difference, depending on where your labels end up. Now, this one here, I might have gone too wide there because I might be over the median. No, that's 3.1. And it depends a little bit on the triangulation that you're picking on underneath. 2.8. Okay, so this is perhaps something we need to check there with the designer, that there is a discrepancy at that point. It's possibly due to the triangulation I'm picking on, but it doesn't seem to be. So that's something you could pick up, and you can question that very easily just by duplicating some labels. Okay, so next, the other way you can check things is using that object viewer I was talking about. So if we want to see a little bit more closely about what's been done between those two surfaces, we can pick one surface, which is my existing, and I can pick the second one, which is my design surface I've been given. I can right-click Object Viewer, and we can have a look at those together in the Object Viewer. So seeing one and the other. Now, where you get the slightly speckled effect as you're moving around, that means there's two surfaces in exactly the same plane. It's trying to show you both. But we can see that the existing ground, which is the magenta one, is that curb is being removed. And if we go underneath the surface, we'll see that if we get the angle just right, our design's going out underneath. Now, sometimes this can be a little difficult to interpret that way, so we don't have to pick surfaces. If we go and pick the actual corridor design we've been given and the existing ground, have a look in the object viewer. Now we can see where their design is in relation to the corridor we've been given, or the actual physical design, if you like, rather than just the surfaces produced from it. So you can see they're running a shortcut line out in the road and then projecting back to the curb. The curb is above the existing ground here, and if we go underneath, we'll see it's below the existing ground at that point and got better slopes coming up. So that's looking good to me. So there's all those little checks you can do. And you can pick, obviously whatever elements you actually want to pick in there. For instance, there is these pipe networks here as well. Now we could individually pick these pipe networks, or we can actually go into what is called the tool space down the side here, if you're not familiar with that, which is a listing of all the civil objects that have been built in this drawing. And you can go to the pipe networks, expand those out. We've got a bit of both. So I'm going to right click on one of those and can select it from there. And you can see it highlighting. That's the existing stormwater and the proposed as well. Select that at the same time. Perhaps my design surface as well. And having done that, let's go to the object viewer again. And now we can actually see my design surface, because I've checked that against, I know, getting an idea now of how that's working in relation to the existing. But if we go underneath, there is all our pipe networks, and you can see that we don't have mismatches and elevation between the pipes and the structures, so that's good. We haven't got any of these new pipes coming in below the existing, so that's gonna work well. And we can do a bit of a visual inspection. You'll see that the lid levels are matching the new design surface levels. So that's all looking good to me. All right, but very, very quick and easy to do visual checks on those. And we can get, and I'll show you later on, numeric checks as well to check grades and all those sorts of things. And that's actually using the new Project Explorer. And just before we move into that, perhaps something else that is useful to use in Civil 3D is we've got a design here, a long section through the new curb. So there's our long section. This may be in model space here, it may be on a sheet. Not sure if I put this on a sheet. Yes, I have. Yep. Okay. So here's a sheet of the design that we've been given. You could plot that out if you wanted to, but you can actually do interesting things or more useful things when you're in this view as well. So if I go into my viewport here, it's just like an Autocad viewport. I pick my long section by picking the gray bands. Up in the ribbon, we get a thing called a station tracker. And if I turn that on in all viewports, it means as I move my cursor through the long section, you can see a cyan line moving through the plan view. And likewise, if I move my cursor into and double click in the viewport of the plan view, as I move my cursor around, I can see a line on the long section. So you can start interpreting where things are, where it's in cut, where it's in fill, etc. But what's actually useful is if I go and try and do this so it shows you at a good scale. Go and look at the markings on the long section. There is a minimum or low point in the curve being marked here. So if I put my cursor next to that, I'm actually going to get the low point being marked in the plan view at the same time with that cyan line. So if I put my cursor there, you can see the low point is actually there in the plan view, not actually where the sump is. So you can want to query the location of that sump. The low point's actually in here, where this little polyline marker is. That's the low point. So very quickly, we can see that we're going to have a problem there unless you resolve that. You might be able to tell that a little bit by the contours, but maybe not. So we've got a good check there as well. I tend to turn those things off when I've finished using them. So some good little easy to use tools that you can start looking at a design that you've been given. Now we're just talking about a little road widening here, but it could be anything, it could be a full road design. You can use all the same sorts of tools, of course. So the next step is to look at this Project Explorer a little bit, this new function in Civil 3D. Came out a month ago, maybe, if that. So you'll find that, I've got to remember where it is, yes, in the add-ins tab in the ribbon. And this is the Project Explorer. So we're going to launch Project Explorer here, once you've loaded it. And this is what it looks like. Now it is a modeless dialog box, so you can click within your drawing and start moving around. You can put it onto a second screen or something like that and have it up all the time. Now, this is probably going to be useful for a number of designers actually to be using this as well. But in terms of getting data or information out of a design you've been given, it's also quite useful. Now, in terms of the way this works, up the top here, we can see there are 6 alignments in the drawing. There's another tab here for assemblies. There are 3 assemblies, and they're actually listed in this first panel. So I've got this one. These are the cross-sectional shapes of the corridor. And there's another one there, and you can actually zoom in and out on those to see what they are. You've got the corridors themselves, and you can actually step through. Actually, it's not a great corridor to do. Let's do the other one. There we go. The curb return corridor, and you can step through the cross sections of that as it widens out. Better slopes change, etc. Stepping through. So a little bit of extra data you can have a look at in here. But what is actually really useful for is getting reports out. So back to the alignments here. One type of report that is often asked for, and it's hard to do in Civil 3D, is to get a profile report. So for instance, if we look at our new curb alignment, and here it gives you a long section of that curb there. If I can adjust the height of that. There we go. Pull that down a bit. There's a long section that we were looking at before. And in that long section, if we scroll down a little bit, there's a number of profiles. And if you pick on each one, it actually highlights them. So that's our existing ground. Here is our curb return design. Now, what might be nice to do is get a report out that gives you the height difference between the existing ground and the design profile. So cuts and fills as a report. You might want also to have certain locations along that profile reported out. So where the changes in straights and curves occurs, where the low points are, for instance, you might want values in the report at those particular locations and get it all out in Excel format. Now, it was difficult to do before because in Civil 3D, we only had this thing called a toolbox, which was pretty much non-customizable. And if we're talking about profiles, there was a station report. There was also a incremental stationing report, but you need to produce these, which would make a Excel type file, and then combine them all together and try and get them all worked out in Excel to actually get the report type that you wanted. However, we can actually do that in here now. So stretching that out so you can see it a bit better. Here is our design, curb return design. And let's just go back to here. Okay, so this is how it's going to look when you first come into here, which is the pretty much reporting out a whole bunch of information for that profile. Station by station, various stations going all the way down there. It's giving bearings, elevations, easting and northings all the way along there. You may not want all of that. So we've got actually the ability to click in one of the cells in there and click on the layout button down the bottom. And then we're going to be able to customize what's been shown down here. So for instance, if we didn't want the easting and northing, turn those columns off. How do you want to justify the columns? Point index, center, all the rest look right, except that's, maybe we don't want the entity type anyway, but you can change your justification in there depending on what you want. You can also do things like change the spacing of these. So this is actually producing every 10 meters. So there'll be a 0 mark. There's others in between. Or is it, yeah. Oh, it's actually got it's got a bit of both. So it's got some default intervals here. If it's just a straight piece of line segment, it's going to give you values every 10 meters. If there's a curve in the profile, it'll give you, in the alignment, it'll give you it every 5 meters. If we scan on through here, we should have a 10 meter mark there. Can't change it at the moment because I'm in this view. But we can change those to what we want them to be. So this is only a short little section of curbs. So let's say we want, if there's any straights, we want every 5 meters. For the curbs, we want every 2. And if we had spirals, we could put every 2 meters as well. And you can choose whether you want the tangent points where a curve turns into a straight as well. You probably do want those. Profile tangent points, critical locations on the profile reported out as well, can all be set up as you want. Now what you can actually do is save these. So there's a save button up the top once you set it up. And obviously you can then recall them by clicking on the open button. So I'm going to go open, and I'm going to go to the profile report and go open, and I've got a pre-set up one here at different intervals. I'm going to go OK. And it's just truncated that table down to just the things I'm asking for, the spacings I'm asking for, and just the columns I'm asking for to go into my report. So obviously you can save that out and use it in any project thereafter. So that being done, to get it out in the report, you come back up to the top panel here. There is my profile that I want to get a report on. I right click on it, and we go quick report to an Autocad table if you want to put it into the drawing, but more often than not, it's going to be a report out to a file or to Excel. So it's going to give it a name. That's probably okay. There's the file types you can do. So I'm going to export it as an XSL. And what we're also going to do is use the layout of the Project Explorer window, which means this layout that we've just customized, that's how it's going to format the report. You can change colors and things in the report if you want, but I'm just going to go OK there. And I'm going to put it out as demo. Curve return design. I'll put it in there. And then we can go and have a look at that file. So it looks like it hasn't worked to begin with, which confused me for a moment, except you've got to realize there's another tab down the bottom here. That is where the data is. So if we expand that one out, there it all goes. Very easy, especially if you've got the presets set up to get that data out into Excel and to save it as a record. And you can go and do your checks on it. So that's your gradient checks of your curve, etc. Very often you want the same sort of thing with the pipes. So if we go and close this for a moment, do the same, well, we won't need to export it. Export's just the same function. But if we go and have a look at the pipes in your drawing, here they are. I'm going to change again the bottom here. If I click in a cell, well, actually we've got the existing stormwater, yep. Click in a cell down here and go to the layout. The things we want to see, we go to the open and bring in the pipe report that we created earlier, or I created earlier, go OK. And now we're getting the relevant data from the pipes being reported out into a table, into Excel file if we export it. Obviously, it's probably more important on the proposed. So now we've got the proposed details there with the easting and northing of the structures, or the sumps. Here's the pipes. And they're all being marked up there with you should have minimum, maximum covers. We've got our, should have grades in here somewhere, I think. Yep, there's the slope on each one. It also tells you if there are rules in the drawing that have not been met, such as these ones. If you hope, it's got a little yellow exclamation mark there. It says that this one is flatter than the 1% minimum grade that was allowed or set up in the drawing itself. Now that may not be relevant to what you're checking, but at least it's going to highlight those, and you can have a quick look at things that are coming out a bit too flat or appear to be too flat, and quickly have a look at those and query them if need be. So a very, very useful little tool just for being able to see and scan through a drawing numerically. All right, so that is the new project viewer. Now, another thing that we wanted to look at was if you've got information from 12D. So we want to bring some, I'm going to close this one, 12D information into here as well and check that. We can do that too. Now the way to do that, probably the most easiest, is to get your 12D design information out as a surface, and they can export it to an Autocad drawing, and you insert your Autocad drawing to compare with this one. So there's a little technique to doing that. We need to basically take the 12D data, which is an Autocad drawing, and convert it into a surface in Civil 3D. Then we can do all our comparisons against it. That being said, it's not a difficult process. You just need to have seen it and done it a couple of times. So I'm going to show it to you now. So what we would do is go to the normal insert command in AutoCAD. So it's I-enter. It's up in the ribbon as well, but why not use the command line? It's nice and quick. And set up how we want to insert this data. So we want to, my cursor comes back, not specify an insertion point. So we want it in the same location that 12D had it, in the same coordinate system. We will explode it when it comes in. We don't want it as a block. We want it as individual elements. And don't want to rotate it. Don't want complete placement. When up the top here, if we come to the button here, now this is the new Insert Dialog Box from AutoCAD. It's changed a little bit just recently. I'm slowly getting my head around it. This button up here lets you import or browse to a drawing. And in here, we've got a 12D drawing export. Now, this is an AutoCAD drawing. It's not a Civil 3D drawing. So it just has AutoCAD faces and a polyline in it. So we go open. And did that work? I'm not sure that one worked. Oh, that's interesting. Why has it gone there? Oh, begging pardon. Wrong surface. Okay, well, that's another good check. Make sure you're working in the right location. That was the wrong drawing. Let's go up one, or up a couple. Boxing drawing, that's the one I was looking for. So we've got the boxing or the earthwork surface for a little car park. Again, we'll read that in, and there we go. So that is information from 12D exported as a DWD drawing. What they end up exporting is these things, which are 3D faces. And also, if you're going to be doing this process, ask for a boundary to be exported as well. It's just a little tick box you tick on. So we've got 3D faces and a boundary, and we can convert that now into a Civil 3D surface and do our volume comparisons. So to convert it, the process is this. Up in the Home tab of the ribbon, go Surfaces, Create New Surface. We'll give it the name 12D Boxing or Earthworks. So it's the bottom surface of a car park before you build the car park on top. From 12D. And style for this, I'll put it onto, I always put it onto triangulated surface when I do this, so I can make sure I'm getting the exact same triangulation that I've been given. That being done, over in the tool space again, where we were picking pipes from before, we've now got a new surface called 12D Boxing, and we expand that out and we add to it some drawing objects, which are the 3D faces. So right click on there and go add. They are 3D faces. We'll maintain the triangulation. We'll go OK, and we'll just simply select all of those. Go enter. And then this is why we asked for boundary as well. There's extra triangles have appeared outside of the boundary. So right click on boundaries, go add outer, it's the outer boundary. And we can choose where that polyline was, and it will pick it. And that is our surface duplicated. So again, like we did before, have a look in the object viewer. Now it's a civil 3D surface, but with all the exact triangulation we've been given out of 12D. And so we can compare that now against our, you can see it's this little car park. I think it's about a 2% slope down, a 2% slope down to a drain in the middle. If we get the angle just right, there we go. Whoops. You can see that in the shading. And a flatter edge around the edge here as well, where the curb's going to be laid on top. Okay, so again, we can compare that against our design surface that we've been given, and have a look at the two together. So it's all actually in cut. It's down, which you'd expect if it's underground. It's down below the design surface that we were given by one contractor, and we can compare another contractor's work, for instance, against it now. So we might be interested in volumes between the two. Okay, how much do we need to excavate for that particular car park? So there's some good and easy tools for doing that as well. Just going to do a save here because I might change the drawing. Do a save as, save it somewhere as your own drawing. Picking any surface, we've got the volumes dashboard here up in the ribbon, which is this button with the red and green symbol. This brings up a window that we can click this button with a red star on it to create a new volume surface. So we'll call this CP volumes, car park volumes. Description of what it is, it's going to be design versus boxing, 12D boxing if you like. Style. Now there is a little style that shows you some colors and you can play around with those once it comes in, but I like to have it on that to begin with. Elevation 2D, ANZ analysis elevation 2D. And then we need to nominate two surfaces to compare together. So the base surface will be the final levels and the comparison surface will be our 12D boxing. Go OK. And the colors will show you where it's found those two surfaces overlapping each other. So that's looking the correct location. And straight away, it's giving me a total amount of cut, how much I've got to cut down to excavate to start building that car park back up on top of, which is good. If you want, you can put some bulking factors in here. So 1.3 and 0.9. And so that was just a multiplier on these other numbers. We'll just adjust that. But for the moment, let's leave that as 1 and 1. We might be interested, though, in knowing some sub areas of this volume. So, for instance, in this location, we have a large stockpile of some sort over the top of the car park. So how much effect is that actually having on this total number? If we remove that, or is it going to make a huge difference? Or probably will, but I can't really tell how much is there from those contours. I can see it's a bit, but how much is it? So what we might want to do is draw ourselves a polyline. So we can just draw this in the background, just a normal 2D polyline of the area that we're interested in getting a volume within, a sub-volume of the of this number that we've generated before. You do need to make sure it's a closed polyline. And it's only going to give us the volume over or where those colors are. Okay, anywhere outside of that, it doesn't. There's no numbers to calculate there. All right, so having generated this, we highlight that in lines, it turns blue, and there is a fourth icon here that says add a bounded volume. So it's bounded by the polyline. So if we pick that and then pick follow the command line, select the bounding object, which is the polyline, the closed polyline, there's a little plus appears here. If you click that, you'll see straight away that the volume within that area is now being reported. So we've got in that area there, it's a bit more than half, maybe 2/3 of the total volume is actually just underneath that stock pile. So maybe it's going to actually be worth getting somebody to remove that stock pile if they want to use it somewhere else first before we have to do excavations for the car park. Again, you can change these things, rename them, call them stock pile. And let's print them out to report. So there's a button here to generate a cut fill report for basically to report out this table. So if I click on that, straight away it gives you an HTML format, XML format report, which you probably want in Excel, to be honest. So you can just go Control A to select all, Control C to copy, bring up Excel and paste it in, and it'll come out columnated. Probably need to work on the formatting of the title, but the important part is the table down the bottom here. Oops. Gives you all that information that came from the table we were just looking at in Civil 3D. So that's pretty easy as well. Okay. You can do as many of those as you want. Just keep clicking this fourth icon and add in as many bounded areas as you want, and it will give you those sub areas as volumes. Okay. Other things we might want to look at is, and we talked about at the beginning, as things we might want to look at is, if I close this table, it should de-highlight everything in the background there, is being able to take this and display it in a 3D view. So in terms of what we were looking at earlier on, we can simply use that object viewer like we did before. So pick as many things as we want to display. So we might want to display, say, the pipes. So I'll pick the pipes again over from the tool space here. Or pick them manually on screen, it's up to you. And go select those existing, select the proposed pipes. You can see them highlighting in the background. Select my, let me see, existing ground, which is the gray contours. And I'm going to select my corridor. And if we do an object viewer on that, we can start seeing all of those things together. So if we play around with my 3D view, and I might want a view like that, to output as a talking point or something to use for public consultation, give people an idea of what we're actually talking about without the need to read plans, etc. So there's a width change there. And those are the pipes looking from underground. And we can simply use this little button up here, which is a save image button. It just takes a screen grab of that. So if I click on that, save it on my desktop, and call it underground. And you can put it in a report and all those sorts of things. Spell it nicely would be good. And we can change our position and look at it above ground as well. Now what we also might want to do, because we're obviously underground here under the EG, we could actually change that surface. So if we close out and we pick our corridor and we pick out design surface instead, that can be useful. In that we're now seeing the top surface level of that. And we can see where the corridors actually demarcates the changes in the surface, because we don't have the other one over the top, the existing. So that's another nice way to do it, another save there, and call it top. Okay, and so the other way to take it the next step is to go and put it into something called Infraworks. Now Infraworks, if you've got the AEC collection, you will have already, and you may have started looking at that. And what that is a 3D, what would you call it, built environment in which your project is being constructed. Now, this model is a bit like a extraction from Google Earth. You can just choose any point on the planet and you'll actually get a model that looks like this. And in this particular case, we're in Sydney here, or inland from Sydney. There's a big quarry over here, and I think there's a lake. Yeah, there's the edge of it there. On this side, a little bit in, it must be on the outskirts of Sydney, I think, on the west. Our little project is in this area. Now, the terrain that comes through is like Google Earth. It's very lumpy. You want to bring in your own design information to add to this particular model. But there's a whole bunch of good stuff we can do. So let's just quickly start doing that, and then I'll show you an end result. So this is we'll take a bit more getting used to the tools if you want to work in this, but there's we do a whole course on this if you're interested. We can actually go and bring in, where are we? Here I've read in already, we can bring in a Civil 3D drawing. There we go. And you can read in certain components of that. And I've actually done that already. So I've got one in here, which is the terrain or the surface. It's the final level surface I want to read in, the one that we've been given by our contractor. And that will simply overlay the surface that is currently in here, the rough one with a more refined one. It knows what coordinate system it's in already, so that's good. That should be all we need to do. Don't drape, that's correct. And so go close and refresh, and you'll see this terrain update. Now, we might need to do one more thing before that happens, which is this. It's in an uncategorized folder. We need to categorize it. So I'm going to go yes. And here it is. Here's my final level surface. I'm going to move it so it's down on top of my elevations from what they call the model builder, which put in all these buildings and things. And I'll turn it on. Now you'll see the terrain will update. Okay, and so we've actually got the curbs and things showing in there. We've actually got also, I brought in the pipes that we had before. They're all showing up underneath there too as well. So you can display those in 3D. Nice thing about this is you can do fly-through videos and those sorts of things, all in with the built environment in the background. Now in this case, some buildings and things have been missed out. They're just not part of the data set for the Google Earth the data set that's come through. You'll see that some places do, some places don't. Depends on how recently the GIS data has been updated for that area. But we can actually sketch our own ones of those, and I might show you that just quickly in a second. But what we can do now is also bring in the colors of that corridor that we had. So if we go into the corridor coverages here, we configure those. I think that's all we need to do. KR1 corridor, we'll close and refresh. And there we go. We've got a nice little colored surfaces showing where the actual new work is going to be done. And we can also, we're missing a little bit there. So there's some rules that need to be added in just to get the color of the curb. There's no curb color, I don't think, being given to that yet. So that's just another part of in here. I'll just do that quickly. Actually, no, I've actually got that already done. So let's just change to just looking at the time we've got, if we want to get a couple of questions in at the end. Go to the finished one here. Now, once you've got that done, you can actually style it up and make this look pretty. And that's what I've done in here. So start putting in the buildings, start putting in a few vehicles, some trees, and it starts bringing the whole thing to life. And again, for people that can't read maps, this is really, really good. Oh, sorry, plans, I should say. This is a really good way. It doesn't take too long to do. I haven't spent a huge amount of time on this, maybe an hour or two, to be able to make it look like what's actually going to be happening in reality and give it some life and some meaning. You've also, this is very easy to make buildings and things look the same way as in reality. So if I wanted to put a new building in here, I could. So I want to do a sketch. So I'll go create a, where are we? They changed the interface on me a little while in here before as well. What do we got here? Structures, building, there we go. We can sketch a building, match it to something existing in reality. Hit escape and choose a facade. And it will have put that in for us. Now you might, don't know how many stories this particular building is. Whoops, missed a vertex. We should be able to actually add in a vertex here. Add vertex. And pull that one over here. There we go. Right, and you can change the number of stories. Maybe that's a few many. This looks like a warehouse of some size, sort by the size of it. But we can also do things like change the way it looks with some presets that are in here already. So there's a lot of stuff we can do in here. Bring up the style palette, just show you a preset. For the facades, let's go into concrete and glass, drag and drop that onto the roof, and now we're getting a completely different looking building. Hours of fun to be had, a lot of fun playing around with this little package. I like that one actually. All right, so that's a little bit on Infraworks. And again, for public consultation, those sorts of things with designs you've been given, you haven't done it yourself, you can bring them into here relatively easily using Civil 3D as a translator. And you could do that with your 12D surfaces as well. All right, last thing we wanted to look at is just quickly, we have the, back in Civil 3D, the ability to take these surfaces we've been working with, and if you wanted to use them in Revit, you can translate through BIM 360. Now, I'm not going to look at the whole BIM 360 process of coordinating with other people using Civil 3D. I'm thinking somebody has submitted this design to you and you want to take that surface data into something like Revit. A completely different package. So we've got a tool in Civil 3D. It's in the, let me see, the Collaborate tab up top, which is this Publish Surfaces. Now you do need to have been given permission to use a folder in BIM 360 to be able to do this. But when you click Publish Surfaces, you can choose what you want to publish. So I'm just going to publish the final levels and the probably the 12D boxing surface that came from 12D. We'll publish both of those out. Choose where to save it. This is where you navigate to that BIM 360 folder that you've been given access to. So I go BIM 360. Here, my project, and navigate to the folder you've been given access to. So I'm going to put it in Civil 3D projects. Adams folder, I think. And it's the platform design shared. No, I'm not going to call it that. Now this makes a drawing file, but it's not a drawing file Civil 3D can use. It's actually just a translation drawing file. It's an unusual drawing format, but it's made specifically for translating between this and Revit. So I'm going to call it consultant. Shared drawing. Okay, and go okay on that one. Now it wants to have a triangulated style on these to make it work properly in Revit. This little thing will actually change that for you as it publishes. So we're okay with that. It'll change it to the triangles when it publishes. So we'll update the style. Okay. And back in, if we're going to have a look at Revit now, just quickly before we finish. Start up Revit. We'll just show you the import for that. Because there is Revit always used to modify the Civil 3D surfaces. Yep, it saved it, so hopefully that's going to be ready to go. It used to modify the triangulation. This process keeps the triangulation. Yep. So we've actually, I have done a bit of testing on this. Let's go and open a new project. I don't want a template file, I don't think. Make it metric. Now I'm no sort of Revit user, but I just should be able to know enough to be able to demonstrate this to you. We go to the Insert tab, and it is a link topography. This is how you read in that exported civil file from BIM 360. So if I go link topography, it'll connect up to BIM 360. There's my project. I did put it in there, didn't I? Might be still updating, actually. It does take a little while to update. However, I have done this one previously, the same export. So I'm going to grab that one. And that should, no. Beg your pardon. No, it's not seeing it there. Let's try it again. Oh, no, there it is. Sorry, I was looking at the wrong image. The consultant one that we did. There we go. I'll link that. Okay, that is because it hasn't finished updating. I have seen that before, so that's okay. We'll use the old one. It does take a few moments to finish writing and get everything through to BIM 360 and update BIM 360. So I'm going to use that one, make a link, and we'll now get that into Revit through BIM 360, and it can be used as an actual Revit topography, and the triangulation is maintained. Now, I haven't set up a coordinate system, so we'll just align it center to center for now. Okay, and having a look at the 3D view. 3D, there we go. Let's put that onto shaded, I suppose, and give it the fine look. And we should see there is our new design surface coming in there, and it's got a nice sharp triangulation that has not been changed. And if we go and look underneath, our other surface is underneath there too. If we get, whoops, if we look carefully, if I get the angle good, there we go. There is our 12D car park surface come through as well. I'll pick that. Okay, and so for those who are Revit users, you can now start using those as topographies with good triangulation, the same as what came out of Civil 3D. All right, and so I think that's pretty much up to time. I'm going to have a quick look to see if there's any questions, but I don't know if there is. I haven't seen many come through. Let's have